We're going to continue with our journey. Let's remember, without going back much in time, the ideas of Aristotle and Ptolemy, who contributed that the Earth was spherical, but thought that the Earth was the center of the universe. Until Copernicus resolved the system, formulated that the planets did not revolve around the Earth, if not that it was the Sun that was static in the center, and the Earth and the other planets moved in circular orbits around it. Let's go a little further with Galileo, who with the help of the discovery of the first telescope and observation, discovered that not everything revolved around the Earth as Aristotle and Ptolemy thought. At the same time, that Kepler modified the theory of Copernicus when he discovered that the orbits did not move in circles but ellipses. And we come in 1687, where Newton surprised us with the law of universal gravitation. With all these advantages, we still continue with the question of how and when did the world in which we live originated. I invite you to go a little further. Let's approach the 20th century, where the new theories emerged, which further revolutionized the ideas of the time, where one of them was the steady-state theory and the Big Bang theory. As we can realize, the ideas of how the universe originated and is formed has been changing over time. As sciences and technology advances, our ability to observe the universe has been increasing. It has made us fixed, giving importance to increasingly distant and small details. The theory called steady-state theory arises from a very broad and general perspective of the universe. It tries to solve some cosmological problems of the time, in which the idea is of a perfect universe and which is based on the so-called perfect cosmological principle. This cosmological principle is a major hypothesis of modern cosmology, based on a growing number of observable clues. He states that on a sufficiently large spatial scale, the universe is isotropic and homogeneous complete, with the conservation of angular and linear momentum respectively. Isotropy means that no matter in which direction it is being observed, we still see the same properties in the universe. Homogeneity means that any point in the universe looks the same and has the same properties as any other given point. An extension of the principle is that of the perfect universe, where the universe is homogeneous and isotropic in both space and time. To any observer, the universe must appear the same from anywhere, in space and at any instant. This time, I'm going to introduce you to James Jeans, because if you were not lucky enough to know him, James Jeans was a British astronomer, physicist, and mathematician who in 1928 was the first of conjecture the cosmology of the steady state. That says that the universe has not had an origin, but expands and creates matter continually. It was the rival theory of the Big Bang theory that was also born during those years. In addition to James, the English astrophysicist Fred Hoyle, the main critic of the Big Bang theory, although he did not discuss George Lemaitre theory, which agreed with Edwin Hubble's observation of redshift, we will see in the following video, that show that the universe was expanded. He did not agree with the interpretation. He believed in an infinitely expanding universe and without a defined beginning. For him, he would never have had a beginning, nor would have an end. The universe had always been constant, generating matter continually. In 1948, he proposed together with Thomas Gold and Hermann Bandy the dynamic and infinite cosmological model of the steady state. He argued that space could be expanding internally and maintaining a more or less constant density. His theory revolved around the creation of new matter, with elementary particles appearing in space spontaneously. The particles could thus form galaxies and stars, and these would appear in the right place to occupy the additional space created by the expansion of space. Whole universe is always infinite, although its size does not change as it expands. He called it the steady state. In the late 1950s and the early 1960s, a group of Cambridge astronomers led by Martin Rayl conducted an exploration of radio wave sources from outer space. This group showed that much of those radio sources must have been outside our galaxy, and also that there were many more weak sources than the strong ones. According to his research, these weak are the furthest and the strongest are the closest. They conclude that the reason for this data has two possible causes. The first being that we were in the center of a region in the universe in which the sources were smaller than in the other regions, but it may also have meant that in the past the sources were more numerous. In both cases, the discovery contradicted steady-state predictions. In addition, in 1965, Penzias and Wilson discovered microwave radiation, which indicated that the universe must have been much denser in the past. Consequently, the steady-state theory ended up being rejected and has to be abandoned. Although the stationary model did not lack supporters at the time, and even Albert Einstein himself at the time subscribed to it, today it is considered discreditable, but formed part of the history of modern cosmology. This is because the best observation of the distant universe show that it is a place in a process of change. I encourage dear Charles, do not get sad. This does not end here. It is time to celebrate and move to our next adventure. I hope to see you soon.